Hello all, in today's class we are going to learn an important topic in database management system, which is timestamp based protocols. Timestamp based protocols are concurrency control mechanisms used in databases to ensure serializability and avoid conflicts without the need for locking. So far we have learned several mechanisms in order to avoid conflicts that arise when multiple transactions takes place at the same time. One among the concurrency control mechanism is the timestamp based protocol. This protocol is also used for ensuring serializability. Serializability is what it is used for allowing the transactions to execute only one after the other. Thereby, what happens? There is no scope for conflicts that can arise, and we can maintain consistent data in the database. Clear. When timestamp based protocols are used, such kind of conflicts can be avoided without making use of the locking protocol. Under locking protocol, we have seen transactions on whichever data item it wants to perform operations. It has to acquire locks. Locks are again divided into shared lock and an exclusive lock. Shared lock is defined as S of A, and when it is acquired by the transaction, it is only used to perform the read operation on some data item, say A. And whereas X of A is used for denoting exclusive lock, and when transaction acquires it, it can perform update operation or write operation on the data item, say A. So likewise, when the transactions are acquiring locks to perform operations, there is no chance that the other transactions can interleave the execution of the transaction which is under the process. So likewise, we can ensure the consistency in the database. And that log-based protocol is also ensuring the serializability, because only one after the other, the transactions are executed. Only once the transaction releases the locks, the other transactions which are waiting under the queue can acquire the locks and then starts their execution. But here, timestamp based protocols can ensure serializability without any conflicts that can arise without making use of the locking. There are several rules that are associated with the timestamp based protocols. Let us see what are they. First is the timestamp assignment. Timestamp assignment says that whenever the transaction is active or whenever the transaction enters into the system, then the database management system is going to assign a timestamp for that particular transaction which is active. That timestamp can be either a system's clock time or it can be a logical counter as well. If it is a system clock time, we know, let us say there are two transactions, say T1 and T2. Let us say T1 has arrived at 10 o'clock and T2 has arrived at 11 o'clock. So from among this, which one is the older transaction? Which means which is the transaction that has arrived first? T1 is the transaction that has arrived first. So the older transactions are given the first priority in the execution of the data item. If not with the case of system's clock time, the timestamp can also be assigned with the logical counter. Let's say T1 has arrived at the time interval 1. Then again later on, if T2 has arrived at some other time interval, then this particular logical counter will be incremented. So the timestamp 2 will be defined for T2. Later, if there exists any other transactions, then again the logical counter will be incremented. So let there be a transaction called T3 transaction, which has arrived later after T2 transaction has arrived. So this is going to increment and provide the value for this T3. Let the timestamp given for T3 be 3. Clear. So either it is going to make use of system's clock time or logical counter. And then this timestamp is not only used for deciding the order of transaction executions, it is also used for recording the information that at what time the transactions has made the read and write operations on the data item. The last time at which the operation has made by the transaction is also being recorded by the database management system. Now let us see what is the second rule. reading or writing rules. Whenever the transaction based on the timestamp protocol, if it wants to execute, it has to follow certain rules. That is read rule and the write rule. Let us read out and understand what is read and write rules. If the transaction T wants to read an item that was last written by the transaction T dash with timestamp T dash greater than timestamp of T, the read is rejected. The read is rejected because it is trying to read a value from the future. Otherwise, it can read the item. Assume that the transactions T1 and T2 wants to perform some kind of operations on the same data item. If T1 is considered as an older transaction, so whichever operations it wants to make on the data item, the transaction T1 has to do it first. If not, at some other time interval, if T2 transaction has made an operation on the same data item, then later on, if T1 is trying to perform a read or write operation, it is going to get rejected. It is because the timestamp given for this particular T2 is greater than the timestamp given for the T1 transaction. This particular rule is also applied with the write rule. Write rule says that when T transaction wants to perform a write operation on some data item that has been read or written by the transaction T dash with timestamp of T dash, if it is greater than timestamp of T, the write is rejected. This is same here in the previous read rule. T wants to perform the read operation. In write rule, T wants to perform the write operation. Whether it is a read or write rule, when the time is assigned to that particular transaction, it has to complete operations on the data item before any other transaction arrives. When T2 arrives into the system and starts executing that particular operations on the data item, at the same interval of time, if T1 wants to do the same operations on the same data item, then what happens? It is going to lead to several other problems. Say consistency problems can arise. The third one, handling violations. When transactions read or write operation violates. If the transactions are executing based on the timestamp based protocols, and then when they want to perform any read or write operation on some data item, if they fails to follow the read and write rules that are defined by this particular protocol, then what happens? Those transactions are rejected and then they need to be rolled back or restart the operations to follow the read and write rules and ensure that it has made the successful transaction. Let us understand what are read and write rules that are defined by the database management system in timestamp based protocols with the help of some examples. Here in the example 1, there are two transactions T1 and T2 with the timestamps 5 and 10. I'm going to write down timestamp of T1 is how much? 5. And then timestamp of T2 is how much? 10. This particular transaction T1 wants to perform the read operation on A. T2 writes item A. T2 wants to perform write operation on the data item A. T1 cannot perform the write operation on A. It is because the timestamp of this T2 is greater than the timestamp of T1. So when some timestamp is given in that particular time interval, T1 has to perform the operations. As it fails to do so, and it is trying to interfere the execution of T2, the T1 transaction will be rejected and it is rolled back. As we have learned in the previous slide that if the transaction fails to follow the read or write rules defined by the database management system, the operations made by those transactions must be rolled back and the transaction has to restart again. Thereby, it ensures the serializability concept. And let us see the second example. Suppose two transactions T1 and T2 with the timestamps 5 and 10. The timestamp of T1 is how much? 5. The timestamp of T2 is how much? It is 10. Now let us see T2 writes item A. T2 wants to perform the write operation on the data item A. T1 tries to read the item A. Here, T1 wants to perform the read operation on A. Now, according to the read rule, can T1 perform read operation on A? It cannot perform. Why? After T2 has written it, T1 cannot perform read operation on A. Might be get confused with the timestamp based protocols. If T1 has arrived first, T1 has to perform the operations. Why T2 is performing write operation and then T1 is performing? Here the timestamp is given. According to the timestamp, these transactions has to execute, right? So if they are not executing at that particular time interval, then only the read operation of the T1 will be rejected. Here T2 is performing the write operation on some data item A and T1 is trying to read the operation of A. Here remember T2 arrived later and how it can perform the write operation on A before T1. So first T1 should complete the operations and then based upon the timing T2 has to perform the operations. As here you can see the timestamp of T2 is greater than the timestamp of T1. These kind of operations will be rejected. Hope you have understood today's lecture. Thank you.